Today we are going to discuss about the topic eigenvalue and eigenvectors. So first we go for introduction. In our daily life we may use many quantities such as distance, displacement, speed, velocity, acceleration, force, mass, momentum, energy, work, power, etc. But these quantities we can categorize into two types. One is for scalar quantity, another one is a vector quantity. Okay, so what is the meaning for scalar? Otherwise, when we say a quantity is scalar, a quantity which contains only magnitude value. For example, length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work and power. All these things are known as a scalar quantity. What is vector? A quantity which contains both magnitude as well as direction. Then we can say that quantity is a vector quantity. For example, displacement, velocity, acceleration, momentum, force, lift, drag, thrust, weight. All these things are known as a vector quantity. So here we can give examples for picture oriented. So volume we can consider as a scalar quantity. Here vector means we can denote it as a direction like arrow mark. So what is the meaning of eigenvalue and eigenvector? An eigenvector is a vector whose direction remains unchanged and it is only changed by a scalar factor if we want to stretch it when linear transformation is applied to it. An eigenvalue is the factor which is used to stretch the eigenvector. If the eigenvalue is negative, then the direction is reversed. Okay, consider the image below in which three vectors are shown. The green square is only drawn to illustrate the linear transformation that is applied to each of these three vectors. So here in that picture we can consider two diagrams. So in the two diagrams we can consider as a three vectors. One is for a horizontal vector, another one is a vertical vector, another one vector is contains angle 45 degree. Okay, if you stretched the green diagram, okay, so here as I can consider as a square, then it is stretched like a rectangle. Then here the horizontal vector, that is a red line, vectors or reals remain same, okay, for vertically and horizontally, but the yellow vector is changed the positions. So from that we can conclude that eigenvector does not change its direction when the images will be changed or stretched. Okay, so eigenvectors, that is a red color, do not change direction when a linear transformation is applied to them. Other vectors, they change the direction. That is a speciality of the eigenvector. Eigenvector does not change its directions if we want to stretch it or we want to enlarge it. We want to discuss some applications of eigenvalue and eigenvectors. So here we mention few real life example where that eigenvalue and eigenvectors are really used in our real life. First one, finance and risk management. The eigenvalues and eigenvectors of a random matrix is used for predicting stock prices and analyzing correlation between various stocks corresponding to different companies and analyzing the risk. Second one, control theory. In control theory, the eigenvalue of the system matrix of a linear system tells you information about the stability and response of your system. Okay, so that is the eigenvalue is of the system matrix of a linear system. They give idea about our system is stable or not. Okay, next one, structural engineering and vibration analysis. The eigenvalues are used to determine the natural frequencies or eigenfrequencies of vibration, and the eigenvectors determine the shape of these vibrational mode. That frequencies are used to evaluate the building bridges and beam based on the sound conditions. So in that structural engineering, eigenvalue is considered as a frequency of that vibrations, and eigenvectors are denoted as the shape of that vibrations. Google search. Next one, Google uses eigenvector and eigenvalues to assign page rank to pages and rank them on Google search. Suppose if you want to search any type of things or content in Google, we can get some order wise related to our content. So how it is arranged in a list for Google. So they used for eigenvector and eigenvalue concept behind that algorithm. So using that concept, they arranged the list. Music. All music is just eigenvalues and eigenvectors. The strings of a guitar, a sitar or shanto, they resonate at their eigenvalue frequencies. The membranes of percussion instruments like the Indian tabla, drums, etc. resonate at their eigenvalues and move according to the two-dimensional eigenvectors. So they making sounds. That sound effect is known as the eigenvalue. That sound moving the direction is known as the eigenvector. In media, that can be considered noise processing like image or sound. The eigenvalues are directly related to the variance of the transformed data, that is used in compression of image and sound. So in that video, the eigenvalue and eigenvectors are used to compress the image or sound. Next, now we are going to our main concept. What is eigenvalue and eigenvector? So now we can define. Let A be a square matrix of order n if Ax is equal to lambda x, where lambda is a scalar and x is a non-zero column matrix, and lambda is called eigenvalue of A and x is called eigenvector of A. So what is a square matrix? Number of rows and number of columns are equal. So this is known as the definition of eigenvalue and eigenvector. So here we can give some examples. Suppose if we consider the matrix A 2, 2, 0, 1, then what is our eigenvector x 1, 0? Okay, suppose if we consider 1, 0 is eigenvector, then we can get the right hand side value as the lambda x, where lambda is a scalar value and x is a lambda is known as the eigenvalue and x is called the eigenvector of the A. It can divide in eigenvalue and eigenvectors. Then only we can say the both cases are equal. So 2, 2, 0, 1, that is a A matrix. 1, 0 is the vector. So now we can multiply these two matrix, we can get the answer 2, 0. How we can multiply? Take it the first row in A and multiply with the first column in X. Okay, 2 into 1, 2, 2 into 0, 0. If you are adding these two values, we can get 2. Take it the second row and multiply with the first column in X. Okay, 0 into 1, 0, 1 into 0, 0. That is the second row in A, first column in X. Then automatically we can, if you add the two value, we can get 0. So next we can get the two matrix 2, 0. Okay, now we can take it 2 as common. Then what we will get? 2 into the matrix 1, 0. So here that vectors are same, 1, 0 is same. So we can write like Ax is equal to lambda x. But here 1, 1 is not a eigenvector because we can't write like a lambda into x. So 2 into 2, 0, 1, that is a matrix. Suppose if we taking 1, 1 as a eigenvector, then if we multiply it first row into first column, okay, first row in A, first column in X. So 2 into 2, 2, 2 into 1, 2, again 2 into 1, 2, then 2 plus 2, 4. Take the second row in A and first column in X. 0 into 1, 1, 0 into 1, 0, 1 into 1, 1. So if you are adding the two values, we can get it to 1. Now we can take it a common value, but it is not possible here. So that is not equal. Ax is equal to lambda x. We can't write that format. Suppose if 1, 1 is a eigenvector, then we can write Ax is equal to lambda x. But here it is not possible because 1, 1, that is a matrix 1, 1 is not a eigenvector. So now how to find the eigenvalue and eigenvectors. So before we discussing how to find eigenvalue and eigenvector, we want to define a characteristic polynomial and a characteristic equation. Let A be a square matrix of order n and I be an identity matrix, then modulus of A minus lambda I is a polynomial in lambda of degree n, and it is called the characteristic polynomial of degree n. How we can write in a polynomial format? Lambda power n minus s1, lambda power n minus 1 plus etc. plus minus 1 whole power n minus 1 sn n minus 1 lambda power 1, then plus minus 1 whole power n sn. So here what is that is s1 and s2 etc. sn all the sum of the roots based on that single term or two term or n terms. So here now we can discuss about what is characteristic equation. Let A be a square matrix of order n and I be an identity matrix, then modulus of A minus lambda equal to 0 is called the characteristic equation of the matrix A. So how we can get this one? Because modulus means determinant of A minus lambda I. So here for understanding I told modulus, but here we can use for determinant symbol because here we can use for matrix. So we can say that is a determinant. So using the determinant concept, if we expand that A minus lambda I, we get the equation lambda power n minus s1 lambda power n minus 1 plus etc. plus minus 1 whole power n minus 1 s into n minus 1 lambda plus minus 1 whole power n Sn equal to 0. So to find the eigenvalue and eigenvector, so how to find out the eigenvalue? Let A be a square matrix of order n and I be the identity matrix. Then the solution of the characteristic equations are called the characteristics root or latent root or eigenvalue of E. We already discussed the characteristic equation. When you solving the characteristic equation, we get a solution. That solution is known as the eigenvalue of A. To find the eigenvectors corresponding to each eigenvalue of lambda, the equation A minus lambda x is equal to 0 process a non-trivial solution x. That x is called the invariant vector or latent vector or eigenvector of A corresponding to the eigenvalue of lambda. Okay, so depends upon the eigenvalue, we can find the eigenvector by using the equation A minus lambda into x equal to 0. So now we can discuss the procedure how to find eigenvalue and eigenvectors. So find the eigenvalue. Let A be a square matrix of order 3. Here we can consider for 3 for easy understand. If you want, you can consider for how much you want. Then second one, construct the characteristic equation of A. Determined A minus lambda equal to 0. So if you simplify that, we can get lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So what is s1? Sum of all leading diagonal elements of A. So in a square matrix, we can add all the diagonal elements. Okay, then we can get it s1. What is s2? Sum of all minors of leading diagonal elements of A. Suppose minus means if we want to find out in A11, then we want to omit the corresponding column and row. The remaining 2 cross 2 matrix we can consider and find the determinant for that 2 cross 2 matrix, that is known as the minor. What is S3? That is a determinant of A 3 cross 3 matrix. So find the solution of modulus of A minus lambda equal to 0, that is known as the eigenvalue. After finding that S1, S2, S3, we replace that, then we find the eigenvalues. How to find out eigenvector? Using the eigenvalue, form the equation A minus lambda into that is x vector, okay, equal to 0, and find the corresponding eigenvector. How we can find out that eigenvector? Take any two row of matrix. Okay, here we can consider 3 cross 3 matrix, but here we can consider 2 rows in that out of 3 rows. Say first row is x1 y1 z1 and second row is x2 y2 z2 in a matrix of order 3 cross 3. So now we can apply rule of cross multiplication. Here first we can take it x1 y1 z1, again we can take it x1 y1 z1, that is 2 times we can write. Similarly for second row x2 y2 z2, not z3, z2. Similarly x2 y2 z2, we can write 2 times. Okay, so omit the first x1 y x2. Similarly for last z1 z2, the remaining part we can consider for finding the cross multiplication. So first one we can take it x1, in that one we can consider y1 z1 y2 z2. Okay, then we can cross multiply it. y1 z2. Okay, here we can consider z3, no problem. So here next minus z1 y2. Likewise we can next consider the second variable y. So we can consider z1 x1 z3 x2. So if we cross multiply it, z1 x2 x1, that is a minus, in between we can use minus, x1 z3. Then third variable z, we can consider x1 y1 x2 y2. So if we simplify it, x1 y2 minus y1 x2. Okay, if we solving the denominator value, we can consider, and using that value we can form a eigenvector x is equal to x y z. The corresponding denominator value is known as the x y z. Or we can consider for constant value k. Okay, then we apply k value, different kind of k value we can get it for different values. To find eigenvalue and eigenvector, we want to note two conditions. If lambda 1 equal to lambda 2, suppose if we say two eigenvalues are same, then a minus lambda I x is equal to 0 has two different equation, then x1 is equal to x2. Okay, if two eigenvalues are same and the two different equations. Okay, we forming a equation by using this equation. If two equations are different, then we can get two vectors are equal. Suppose if two eigenvalues are same and all the equations of a minus lambda I into x is equal to 0 are same, then we can get it x1 not equal to x2. That means we can get different eigenvectors. Okay, now we can solve one problem. Okay, take the given matrix A, that is a 3 cross 3 matrix, 2 minus 2 2 1 1 1 1 3 minus 1. So now we forming a characteristic equation. So what is the formula for forming a characteristic equation? Model determined a minus lambda I equal to 0. So what is the expansion for this one? Lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So now we can find out s1 value. What is s1? Sum of the leading diagonal elements of A. So here what is the leading diagonal element? That is a upper, from that upper corner to lower corner. Okay, we can consider the value 2 1 minus 1. So if we add these three value, we can get it 2. Now we can find out s2 value. So s2 means sum of the leading diagonal elements of A. So here how we can get the first one? 1 1 3 minus 1. If you want to consider 2, then omit the corresponding row and column. Okay, first column and first row will be cancelled. What will be the remaining? 1 1 3 1. If you want to consider minus 2, that is the second value, then first row and second column will be cancelled. So we can get it 1 1 1 minus 1. Okay, now we are going to find out the second minor value. So how we can find out? By using the diagonal element only. Okay, so if we consider the second elements in the diagonal element, that is the middle one. Okay, if we cancel second row and second column, okay, then what will be 2 2 1 minus 1. So again we can consider for the third element in the diagonal value, that is minus 1. Okay, we can remove the corresponding row and column, that is third row and third column. We will get 2 minus 2 1 1. So now we can simplify it by using cross multiplication. 1 into minus 1, that is minus 1, then minus 1 into 3 minus 3. So if you adding these two value, we get minus 4. What is the second one? 2 into minus 1 minus 2, then 2 minus 2 into 1 2. So minus 2 minus 2 minus 4. Then third one, 2 into 1 2 minus 2 into 1 2. So we can get 2 plus 2 4. So what is the value? Minus 4 minus 4 plus 4. If you are adding all these value, we can get minus 4. Okay, that is a S2 value. Then we want to find out S3 value by using the determinant of the given matrix. Okay, take it the matrix 2 minus 2 2 1 1 1 1 3 minus 1. Here first we can take it the first element in the first row 2. Then we want to find out the minor values, that is we can cancel it for first row and first column. We can get 1 1 3 minus 1. Then we can take the second element in the first row, that is minus. We can use first minus for second term. Then into minus 2. If you omit first row and second column, we can get 1 1 minus 1. Then we can consider in the first row third element, that is a plus 2. Okay, if we cancel first one third column, we can get 1 1 1 3. Then you can cross multiplication. Using that cross multiplication, we already discussed how to find out that value. Okay, if you simplify it, we can get S3 value is equal to minus 8. So using this S1, S2, S3 value, we form the characteristic equation. Okay, already we know that what is characteristic equation? Modulus of A minus lambda equal to 0, that is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. We apply S1 is equal to 2, S2 is equal to minus 4 and S3 is equal to 8. So if we apply these values, lambda cube minus 2 lambda square minus 4 lambda plus 8 equal to 0. So if you solve this equation, we can get lambda is equal to minus 2 comma 2 comma 2. Okay, if you want to, we can apply trial and error method. Okay, so we can easily get it. The first term will be 0. Here I will show that 1 minus 2 minus 4 8. Then we can take it the first element in the second row as 0. So 1 minus 0 1. Then we can multiply with trial and error. First we can check it 1, then minus 1, then 2. Okay, now we can take it for 2. So 2 into 1, we can put it the second element 2. Then we can subtract minus 2 and 2 0. Then we multiply this 0 into that root 2. Okay, so 2 into 0 0. So minus 4 0 minus 4. Then 2 into minus 4 minus 8. So 8 minus 8 0. So what is the remaining value? 1 0 minus 4. So that we can write lambda minus 2 into lambda square plus 0 lambda minus 4 equal to 0. Now we can find out using these terms, lambda is equal to 2 and another one lambda square plus 0 lambda minus 4 equal to 0. Now we can simplify that lambda square minus 4 equal to 0, that is lambda minus 2 into lambda plus 2 equal to 0, because a square minus b square means we can write a minus b into a plus b. Likewise we can write the expansion. So from that we can get lambda equal to 2 comma minus 2. So what are the eigenvalue we have? Minus 2 2 comma 2. So now we can find out the eigenvector by using the eigenvalues. So solve the equation a minus lambda I x equal to 0. So here we can put lambda value is equal to 2. So then 2 into that I means identity matrix 1 0 0 0 1 0 and 0 0 1. So you can multiply with 2 means we can get for, or minus 2 means we can get for minus 2 0 0, then 0 minus 2 0 0 0 minus 2. So we can simplify it, we can get it 2 minus lambda minus 2 2 1 1 minus lambda 1 1 3 minus 1 minus lambda. So we can consider that x is x1 x2 x3. Okay, so now we can apply lambda is equal to minus 2. That previous is we can write in a general format. Now we can apply for lambda is equal to minus 2 from a. So we can get 4 minus 2 2. If we put for lambda is equal to minus 2, then minus minus plus. So we can get 4 minus 2 2 1, then minus minus into minus 2 plus 2. So 1 plus 2 3. We can get it second row and second value, then 1, and then third row 1 3 minus 1, then minus of minus 2 we can get plus 2. Okay, minus 1 plus 2 we can get 1, then into x1 x2 x3 equal to 0. So now we can take it first one multiple with the first column in x. Okay, so 4x1 minus 2x2 plus 2x3 equal to 0. That is the first equation. Take it the second row and multiple with that column matrix 1x1 3x2 plus x3. Okay, if we can add multiple, then we can add it, we can get the second x1 plus 3x2 plus x3 equal to 0. Okay, likewise we can go for third one, third row and that first column matrix. Okay, x1 3x2 and plus x3 we can get for third equation. So we can get three equations, 4x1 minus 2x2 plus 2x3 equal to 0. That is the first one, 4x1 minus 2x2 plus 2x3 equal to 0. Second one, x1 plus 3x2 plus x3 equal to 0. And third one is x1 plus 3x2 plus x3 equal to 0. So solve the two distinct equation 1 and 2 by the rule of cross multiplication. We already discussed that. So we can take it two different equation 1 and 2, because the equation 2 and 3 are same. So we can take it that here we can write the coefficients values 4 minus 2 2, then 4 minus 2 2, then 1 3 1 1 3 1. Okay, we can apply whatever method we discussed previously, then write in that format x1 divided by here minus 2 into 1 minus 2 minus 2 into 3 6. So first one we can get x1 by divided by minus 2 minus 6. Similarly we can find out x2 divided by 2 minus 4 equal to, similarly we can find out x3 divided by 12 plus 2. So if we simplify it, x1 divided by minus 2 minus 6 minus 8, x2 value 2 minus 4 minus 2, x3 value 12 plus 2 14. Okay, so here 2 is common for all the denominator value, so we can multiply with 2, then we can get it x1 by 4, x2 divided by 1 because we multiply with minus 2, x3 divided by minus 7. So from that we can take it, therefore x1 is equal to 4, x2 is equal to 1, x3 is equal to minus 1. So when the eigenvalues is minus 2, then we can get x1 is equal to 4 1 minus 7. So similarly we can find out the second eigenvector by using lambda is equal to minus 2. So here we can put it for 2 minus lambda value. Okay, here we can consider for 2, not for minus 2. Okay, then so 2 minus 2 0, then minus 2 2, then 1 minus 1 1 1 3 minus 3, then x1 x2 x3. Again we can using the matrix multiplication we form the 3 equation. 0 x1 minus 2 x2 plus 2 x3 equal to 0, x1 minus x2 plus x3 equal to 0, x1 plus 3 x2 minus 3 x3 equal to 0. So using this 3 equation, by using the cross multiplication method, we find out x1 equal to 0, x2 2 and x3 2. Hence the eigenvector corresponding to the lambda is equal to 2 is 0 1 1. Okay, again we can take it when lambda is equal to 2, because the previous case also we can consider lambda is equal to 2 only. So both values are same. So the both eigenvectors x2 equal to x3 equal to 0 1 1. Hence the eigenvalues are lambda is equal to minus 2 comma 2 comma 2, and eigenvectors are for lambda is equal to minus 2 into, and eigenvectors are x1 is equal to 4 1 minus 7. Suppose for eigenvalues equal to lambda 2, then the two vectors x2 and x3 equal to 0 1 1. So we find out all the eigenvalues and all the eigenvectors of the given matrix. We already discussed the property that suppose two eigenvalues are same and we have two different equations, then we get two eigenvectors are same. So here we have two eigenvalues are same and also the two equations are different. If you forming the equation by using a minus lambda I into x is equal to 0. Okay, so now we can get it, two vectors are same. So thank you once again, thanks a lot.